Hello and welcome to today's problem 297, serialize and deserialize a binary tree. So, to give a little bit of context, serialization is when you convert a data structure or an object into a sequence of bits or otherwise so that it can be stored somewhere and then transmitted across the network, etc., before it can be deserialized back into its original form afterward. For this problem, what we have to do is take a binary tree, serialize it in any sort of way, there's no restriction on it, and then make sure that this binary tree can be deserialized to the original tree structure. So, so constraint here, we need to make sure that the binary tree can be serialized to a string, and yeah, there's nothing else afterward which we need to take a look for. Okay, so an idea for this would be to convert this binary tree, like for example, we have 1, 2, 3, 4, 5, we can convert that into a string in preorder format. So to give a little bit of context of what preorder format is, it's basically when you recurse through from the the left one before going on to the right one, the left node to the right node. So let's say like we start off at 1. We call a DFS, we do a DFS in preorder format. So what we do is we go to 2, and then from 2, we go check to see what 2's left child is. There's nothing. It's null. After we successfully know that it's null, then we go forward to the right. We check to see if anything's in there. There's nothing. And then we're done that. We recurse back up, and then we go ahead and check the right child of the original root, which is 1. We check this one's left, 4. We check this one's left again. There's nothing. We check this one's right. There's nothing. And then we move on, so on and so forth. An idea to convert this binary tree and make sure that all the data is retained is you can convert it into preorder to an array of the values in preorder format, representing the null values as just, let's say, like the number n, for example, or like the letter n, for example. Since we can represent these values as a null value, let's say we have like an n here and an n here, when we deserialize the tree afterward, we're able to tell that a node is a leaf one by checking the left and the right to see whether or not those values are equal to n. If it is, then we would successfully know that it's a leaf node. And then from there on, using that preorder array, we can then deserialize it afterward and convert it back into its original form, basically knowing it from just those, from the leaf nodes and the preorder format. So, okay, so to run through an example of this, we have, let's say this root, 1, 2, 3, null, null, 4, 5. We can first serialize it, what we want the output of this to be, given this one. We want to start off at 1, and then we want to recurse through. We have to have some sort of way of denoting the difference between it. So we can use a comma, and then we can go ahead and add the left child 2 before taking a look at what its left child is. Since it's null, like I said before, we can represent it as n. And same thing with its right one. We go ahead and check this one, the value to the the sub value, the right child value of 2, it'll be n again, and then we'll move forward back onto 3 because preorder goes back to the root. It's finished everything on the left and now it goes to the right. So we go ahead and hit that one, and we go to 3, and then we hit 3, and then we check its left one. We hit 4. We know everything on the left of 4 is null, so we can convert it back into here. We know everything to the right is null, so we can convert it into null again. And then we'll curse back up. We'll go ahead and hit 5 again. We'll hit there. And then since everything to the left and to the right is null, we'll hit those two. So we're given this. We want the serialization method to return this as a value. Now, from this one afterward, for our deserialization method, we'll go ahead and make this a comment actually. We'll go ahead and we'll be able to deserialize this by walking through this again. So let's say that we have here our serialized string. We'll walk it through. At 1, we're going to want to create a node. So we want to create a node if not n. And then since we know that our order is going to be preorder, we know that the next thing is going to be to the left of it. So we'll put then we'll then put like, since we know it's preorder, create node, create left subnode to the left, and yeah, let's go ahead and do that. The next thing we have to know is since leaf nodes have a left and a right value, well, left and a right sub-child of null, if we're able to discern that it's a leaf node by doing that, we're going to want to know that like that's the leaf node, and we're going to want to keep moving forward. So we'll go ahead and check if n keep moving forward. So let's say like we hit 2, for example. We just created that node, so we have a 1 and a 2 created so far in our deserialization method. We check to see, oh shoot, these values are both null, so we're going to want to keep moving forward. We're going to want to keep incrementing, and then now we know that this value is going to be at the right. We know 3 is going to be at the right because this one's a leaf node, so we can continue on going forth. We go ahead and check 4. We know 4, since it's like right there and it's directly to the left, so we can add that. And then we know like that it's a leaf node by knowing that these 2 n values are there. We keep moving on forward, hit 5, we know it's to the right, then we keep going on and so forth. So yeah, we can go ahead and well, now that this has been explained, what we can do is go ahead and begin creating the serialization process. So yeah, what we're going to want to do is, right, so first we're going to want to create a result array. So we want like basically an array, something similar to this, and then at the very end we're going to want to append everything together, all of these values. So we're going to want to do res.append using the comma, or actually wait, that's not the right syntax. We'll do comma.join res in order to effectively add everything in the array together, like all of these values, and then separate them with a comma, so we have it in string format. And then we're going to want to return that value afterwards. Okay, now like we said before, we're going to want to traverse through pretty much. We're going to want to have a DFS method, which takes in the current value and then performs the DFS adding it to the string. We're going to want to do DFS on the root at the very beginning, and from here we want to add the current value. Since we're doing it in preorder, the format for preorder is doing a DFS on the cur.left, DFS on the cur.right, and then since we're doing it before, we're going to be doing it here. So we're gonna go ahead and append that. So res.append the current value, and we want that to be in the output of a string. So we're gonna want to surround that and turn that into a string over there. So yeah. So basically we're gonna append that value. If we hit a leaf node, for example, well, if we hit like a null node, we're going to want to append n to that thing for the reasons we mentioned earlier. So we're going to want to do if node doesn't exist, what we're going to want to do, if the current one doesn't exist, what we're going to want to do is we're going to want to append, let's say n to the like results array. And from there, we want to keep on going forward. So, we want to basically return, finish that DFS, basically that DFS method currently there. And then, so we'll do this. And then we'll go ahead, recurse through, and basically serialize this string. So, yeah. So just to walk through this again, we call in DFS on the root. We check to see if it doesn't exist. If we do, then we append n, we return. Otherwise, what we're going to want to do is keep on appending the string value of the currents, and then call the DFS on the left and then the right. So yep, we'll do that. Well, at the very end, we'll have the string over here. Next thing we can go ahead and do is begin the deserialization. So it'll be kind of the same thing, same concept over here. We're gonna go ahead and do a DFS. First of all, what we're going to want to do is, given the data, we know the data is in this format, we want to split it and convert this back into an array. So we can go ahead and do data, well, I guess like values equal data dot split using a comma. So now we have an array, and from this array we need to have some sort of pointer that keeps track of where you are currently in the iteration of the pre-order string that we're doing that, because we need to check like what we've already gone through. So what we can do is we can create a global variable, like a global variable called I, which will be referenced in all DFS methods. So basically the reason why I'm making this an array is because arrays are immutable. Integers are immutable, meaning that if you call like a DFS referencing that method, it'll run into problems. So since lists in Python are immutable, we can go ahead and do this. So when we modify that value in the DFS methods, then it won't run into any issues. So we'll go ahead and do that. We'll initialize it to the value of 0, since we're starting at the 0th index, and then we can begin deserializing it. And how do we do that? We use DFS. So we'll go ahead and DFS on the current one. So same format, we do DFS on the very first value. So we're going to want to, I guess, like return that value of the current. Actually, we don't need this current value because everything's in the string already. So we're going to want to just call DFS like that. Okay, so from there, first thing we need to do is we need to be able to check to see whether or not the value is n. So if it's n, that means we're going to want to pretty much just iterate. So since we're given this, we want to iterate forward, because we know since an n, it's an empty. We wanted to note in some way that basically it should have an empty node over there. So what we can do is if not cur, we want to return nothing, and then we also want to increment that I value by 1. So we'll go I0 plus 1, or plus equals 1. Okay, so in scenarios where the value is not null, what are we going to want to do? We're going to want to create a new node based off of that string's value. So we're going to want to do node equals the tree node class over here. We're going to want to instantiate a new instance of it, and then we're going to want to create basically the integer representation of the current item in that vals array, vals at the index. So we'll do vals at I index 0 because it's a list, and then from there we've instantiated that value. What we're going to want to do is we're going to want to increment this value, or like increment it by 1, so we move on to the next value in the value string over here. So from there, what we're going to want to do is we're going to want to attach this value and run the same method on the left and the right. So traditionally a DFS method passes in a cur parameter to keep track of where you're at. Since this is a string, we don't need to do that. It's incrementing it automatically, so we can just do this. If not cur, or actually, for this one, this should be if not cur. This should be if vals, or if vals at the current index is equal to n. That's when we should do it. My bad, sorry. A little brain hiccup. Okay, yeah, right. So this will take care of the empty value of like the values in which it's equal to n, where it'll create a node which is empty and then attach it to the left or the right. This one will handle the case where it's the current value. It'll convert it back into a integer and it'll increment it forward. So it'll increment past the forward to the string. It'll keep going on, so on and so forth. And then from here, that's when we actually start to do with this node, we want the node's left value to be a DFS call, or I guess we need to do, DFS call on the left. And then we can do node.right to equal DFS call on the right. And then at the very end, we can return the node. And since this is at the 0th index, it'll have all the attached on the right. So DFS, basically DFS traversal, we can return this node value and have that as our final value. So at the very end, we're going to just want to call this and return the value of this as the final result. So yeah, just to walk through this again. First, we serialize the string, we do DFS traversal, representing the empty nodes as n. So we'll go ahead and we have like that case over here. If the current doesn't exist, and we append n, we return, and then we basically convert it to a string, call DFS on the left and the right, and have this as the final result of the serialization method. Afterward, what we do is we split the data back into commas. We have basically a global index which keeps track of the current item we're on. From there, we convert all the ones that are n. If not, good catch. Okay, sorry. We check to see if the vals I is equal to n. If it is, then what we do is we iterate it forward by 1 and then return none, which will then be created for this DFS method over here. It'll create a none value, and it'll just be a leaf node for its parents. And then for values where there is something, you convert it back into an integer, set that as the value. Well, you initialize that as the value, and then you increment it forward, and then eventually you'll return the root of the final tree again at the very end. So we'll go ahead and run this. Yeah, it's accepted. We can go ahead and submit. There you have it.